Welcome to Ganit Online. So this is the continuation of the previous video. In the previous video, we have learned about how to find the limit when it exists, like how to find the limit of a particular function at a point, whether it exists at that point or it doesn't exist at that point. You have to find it out. So that is the main objective of these problems. So this is also of similar sort, but the function here is defined at three intervals. There in the previous video, we have seen that the function is defined at only two intervals. So you have to take this point into consideration. So now, so he's asking us to find out the limit at a is equals to 1. So x is less than 1, you have to use this function, and x is greater than 1, you have to use 3x. So that's it. For x is less than 1, or for 1 minus means 1 minus h, you have to use 2x plus 1, and for x is greater than 1, it's 1 plus is 3x. For that you have to use 3x. So yeah, now let's solve. Left hand limit is equals to limit x tends to 1 minus. 1 minus means we have to take this function 2x plus 1. You have to take 2x plus 1. So which implies limit x tends to 1 minus h 2x plus 1. Okay. So this is equals to limit h tends to 0. You have to substitute 1 minus h in the place of x. 2 into 1 minus h plus 1. So now you have to substitute 0 in the place of h. So 2 into 1 is 1, sorry 2 plus 1. So this is 2 plus 1, which is equals to 3. So let's name it as equation 1. So now right hand limit. Right hand limit. What is right hand limit? Limit x tends to 1 plus. You have to select 3x function. So this is equals to limit x tends to 1 plus h. This is equals to 3 into 1 plus h. Clearly, if you substitute limit h tends to 0, this is what? 3 plus 3h. So this is equals to 3 plus 3 into 0, which is equals to 3. This is equation 2. So now if you observe equation 1 and equation 2, at the point 1 minus and at the point 1 plus. So the limiting value at the point of 1 minus and the limiting value at the point of 1 plus, both are same. So the left hand limit and right hand limit are equal. So then the limit exists at the point x is equals to 1. So this is the first problem, I think. So we have solved where the limit exists. Yeah, so now conclusion. As left hand limit is equals to right hand limit, as left hand limit is equals to right hand limit, limit exists at x is equals to 1. Limit exists at point x is equals to 1. So yeah, that's it in this problem. So let's move to the next problem. So the second problem is also of similar sort. We have to find out whether the limit exists at a certain point or not. F of x is equals to x square when x is less than or equals to 1, and x when x is between 1 and 2, x minus 3 when x is greater than 2. A is equals to 2. Yeah. So now we have to check whether the limit exists at 2 or not. So left hand limit, same thing, hand left hand limit is equals to limit x tends to 2 minus, which is equals to x. Here limit x tends to 2 minus h x. Okay. Now limit h tends to 0, 2 minus h, which is clearly 2 minus 0, which is equals to 2. So the left hand limit is 2. This is equation 1. Now right hand limit. Right hand limit is equals to limit x tends to 2 plus. You have to select x minus 3 function. Okay. Again, if you are confused why you are selecting x minus 3, so this is greater than 2, right? So 2 plus is greater than 2. In this category, we have the function f of x is equals to x minus 3. That is the reason I have taken here x minus 3. Okay, now, so which is equals to limit x tends to 2 plus h x minus 3, and here limit h tends to 0, 2 plus h minus 3, which is equals to limit h tends to 0, h minus 1. This is equals to 0 minus 1. Clearly it is minus 1. Let's take it as equation 2. Clearly left hand limit and right hand limit are unequal. That we can say. So left hand limit is 2 and right hand limit is what? Minus 1. So both are unequal. So does the limit exist? No, the limit doesn't exist. Yeah. So limit doesn't exist at what point? At x is equals to 2. So as left hand limit is not equals to right hand limit, limit does not exist at x is equals to 2. So yeah, so this is it. So this is in the problem. So this is a solution of the given problem. So by this problem I think you are clear how to solve this sort of problems. So this sort of similar models how to solve, I think you are clear by now. Now let's go to the other problem. Here he is asking to show that he is asking for the proof that limit x tends to 2 minus mod of x minus 2 by x minus 2, this is equals to minus 1. Now solution. Here he has used, so we know that mod x is equals to x for x is greater than 0, mod x is equals to minus x for x is less than 0. Okay, so then now you have to understand this one. So if x is positive, then mod x is equals to x. If x is negative, then mod x is equals to minus x. So similarly mod of x minus 2 is equals to x minus 2 if x minus 2 is positive, yes or no? So if I throw this minus 2 here, right side, then it will become, okay, I'll be writing in detail. X minus 2 is greater than or equals to 0. Minus of x minus 2, x minus 2 is less than 0. Again, we have to write mod of x minus 2 is equals to x minus 2 when x is, I am throwing this minus to right side, so what it becomes, positive. And next, minus of x minus 2, x is less than 2. So this is the definition. So here, now let's come to the question. So then what we have understood from this definition of modulus of x, if x is greater than 2, then mod of x minus 2 is x minus 2. And if x is less than 2, mod of x minus 2 is minus of x minus 2. So that we have understood. Now in the problem, x minus 2 by, so limit x tends to 2 minus, so which in the sense 2 minus, in the sense what, 2 minus h, modulus of x minus 2 by x minus 2. I'm taking LHS. LHS. Okay, LHS is this one. So what is 2 minus h? Limit x tends to 2 minus h means less than 2. So if it is less than 2, which function you have to select? This is greater than 2, right? If it is greater than 2, then you have to select x minus 2. If it is less than 2, why I am taking less than 2 here? 2 minus h. H is very small, very small. So 2 minus very small number is less than 2. Yes or no? It's like something, it is 1.999 like that. Okay. So that is less than 2. So which function you have to select in this interval? As x is less than 2, you have to select minus of x minus 2. Okay. So now minus of x minus 2 by x minus 2. Okay, so this both things gets cancelled and will be remained at minus 1. So this is LHS. So this is LHS we have arrived at. So minus 1 is what? RHS. So LHS is equals to RHS. Therefore LHS is equals to RHS. So therefore limit x tends to 2 minus mod of x minus 2 by x minus 2 is equals to minus 1. Hence proof. So that's it in this problem. We have proved it. We'll move to other problem. So other problem is what? Show that limit x tends to 0 plus 2 modulus of x by x plus x plus 1. This is equals to 3. This is equals to 3. You have to prove it. Solution. First we have to know. We know that modulus of x is equals to x when x is greater or equals to 0. It is minus x when x is less than 0. Now let's solve the problem. Consider LHS. Consider LHS. So how to solve these type of problems? We have to take LHS and we have to apply all the formulas and we have to reach at RHS. So if you solve all the left hand side problem, then you should reach at a point which is equals to RHS. Then our problem necessary objective is fulfilled. So that is the type you have to follow while solving these type of problems. Consider LHS. What is LHS? Limit x tends to 0 plus 2 modulus of x by x plus 1. So here you can say, what is x tends to 0 plus? X tends to 0 plus h, 2 modulus of x by x plus 1. So 0 plus h. So what is the definition of modulus of x? 0 plus h. So 0 plus in the sense what? Greater than 0. 0 plus little less, little greater than 0 means 0 plus 0.00001. So the value is 0.000145678 like that. Okay. So then in that case you have to select x. Greater than 0 is x. So I am writing here. Sorry. I am writing a limit x tends to h. So modulus of x, h is what? A positive number. So it is 2 into x by x plus 1. Okay. Now, so this x and this x gets cancelled each other. Now limit h tends to 0. H is tending to 0. So you have to substitute what? 2 plus h plus 1. So which is equals to 3 plus h, which is equals to 3 plus 0, which is equals to 3. So what is 3? 3 is what? RHS. So this is equals to RHS. So therefore LHS is equals to RHS. Therefore what is LHS? Limit x tends to 0 plus of 2 times of modulus of x by x plus 1 is equals to 3. Okay, so this is the final result we have obtained. So this is the final result we have obtained. So hence proved. Let's move on to other problem. So these problems are very interesting actually. So the basic idea of this problem is that you have to be in a position to solve any sort of limit problems. Like you should know how to check the limit, and you should be in a position to understand the definition of modulus of function. And in the future, in the next problem, we'll be understanding about the definition of a greatest integer function or least integer function like that. Okay. So now we'll solve the problem. Compute limit x tends to 2 plus modulus of x plus x. Okay. And limit x tends to 2 minus modulus of x plus x. Before solving this problem, let's understand what is modulus of x. So modulus of x, suppose say f of x. So modulus of 2.5, modulus of 1.99, modulus of 1.0049. So what is this number? It is greatest integer function. Okay. So we have to see whether the best possible integer here. Okay. Here the integer is 2 plus 0.5. You can say it as 2 plus 0.5. So we have to eliminate this 0.5 and we have to get 2. We'll be getting 2. Here 1 plus 0.99. Eliminate this one, we'll be getting 1. Here 1 plus 0.0049. Eliminate this one, we'll be getting 1. So greatest integer function. So this is the greatest integer function. This function name is greatest integer function. And next we'll be checking for the negative values. So minus 1.9, minus 2.04, minus 0.59. So what I've told, this is the, so you have to check the high, you have to consider the higher value of the integer or lower value of the integer. So you have to consider the lower value of integer. So here you should write as minus 2. Then what? Minus 2 plus 0.1. Eliminate this one, you'll be getting minus 2. Greatest integer function. This is minus 2, minus 3. Yes, next. You have to consider minus 3 or not? Yes, you have to consider. Then what? Think. Minus 3 of how much is equals to minus 2.04. X is equals to 3 minus 2.04, which is equals to how much? Come on, think. Point 96. So 3 plus 0.96. Omit this one, you'll be getting minus 3. Here minus 1 plus point, how much? 4.1. Minus 1. So the function, the graph of this function is, so this is x-axis and this is y-axis. The points are 0, 1, 2, 3, 4. Minus 1, minus 2, minus 3, minus 4. 1, 2, 3. Minus 1, minus 2, minus 3. Now let's plot the graph. So from 0.1. So if you put here, this is 0.1, yes or no? If it is 0.1, what value it is? Answer is 0. So at 0.1, it is 0. At 0.5, 0.5 value is 0. At 1.5, at 1.5 value is 1. So jump here, 1, somewhere here. Okay, if you are getting confused, I'll be plotting all the values which you have taken. 2.5, x is 2.5, what is y? 2. 2.5 comma 2. 2.5 is somewhere here. 2 is somewhere here. Okay, yeah. And next, so in that way, I'll be asking 1.5 is what? 1. Greatest integer function. 1.9 is what? 1. So we can say that the all the values which we input to a function, so from right from 0 to here, so 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.9999999, up till that point it is 0. So can I draw in this way? But I should not include 1. If it is 1, the value is 1, means it will be jumping to this point. If it is 1, the value is this one, it is jumping, and you should include it. And At this point it is discontinuous. At this point it is discontinuous. At this point it is discontinuous. At this point, so this gap will be filled by this point. This gap will be filled by this point. So this gap will be filled by this point. Why? A greatest integer of 3 is what? 3. So this one. All these are not beyond your IPE level, but I am explaining you for the clear understanding. So here we'll be checking for the negative value. So 0 minus 0.5 is what? Minus 1. Yes or no? So minus 0.5 here, suppose somewhere here. Okay. So minus 0.1 is what? What? Minus 1. So here minus 1. But 0 value is what? 0. So it is, this gap is filled by this one, and this gap is open, and here it is straightforward till here. This is filled, again straightforward here. This is filled. Again here, this is open, this is filled. So this one. So isn't it? So if you observe here, just out of curiosity, I am drawing this one. So if you observe here, I'll be taking red color. Yeah. So if you are standing here, suppose it is like step function, na? These are all like steps, na? Yes or no? So this function is known as greatest integer function. So in competitive exams, directly they will be taking this concept into consideration, and they will be asking some other problem where this concept is used. So directly you should be in a position to understand. So this is the step function. So we'll be stating it as a step function. I think now you are very clear about all the greatest integer function and how these values are there. Okay, so this red color is not the graph. So actual graph of step function is in green color. In green color. Yeah, so this is the concept required to solve this problem. Now let's solve the problem. So here we have two parts. So first part is what? Limit x tends to 2 plus greatest integer function plus x. So no, so this solution. Limit x tends to 2 plus h modulus of x plus x. So which is equals to limit x tends to 2 plus h 2 plus h plus 2 plus h. So clearly 2 plus h of greatest integer function. So this h is neglected. So we will be writing only 2 here. And here again 2 plus h. Limit h tends to 0. This is equals to 4 plus h. This is equals to 4 plus 0, which is equals to 4. Clearly the value of limit x tends to 2 plus greatest integer function of x plus x is 4. I'll be naming it as equation 1. Now second part. Limit x tends to 2 minus greatest integer function of x plus x. So this is left hand limit. So previously we have found out the right hand limit. Solution. What is the solution? Limit x tends to 2 minus, in the sense 2 minus h, where h is very small. Here function of x plus x. So which is equals to limit x tends to 2 minus h. 2 minus h plus 2 minus h. Greatest integer of 2 minus h is what? So less than 2. So what does that mean? So suppose it is around like 1.5 or 1.99 like that. So that is 1. Okay. So what we can say? So 2 minus h is what's approximately 1.99. So the value is 1. So next plus 2 minus h. So which is equals to 3 minus h. Limit of h tends to 0. Limit of h tends to 0. So which is equals to limit. So I think you are clear or not clear. Okay. So 3 minus 0, which is equals to 3. This is equation 2. So left hand limit is 3 and right hand limit is 4. Does the limit exist? No. As left hand limit is not equals to right hand limit. Limit does not exist at x is equals to 2. This is the conclusion of this problem. Okay. So my lines for these boxes are uneven. Please don't mind it. Please only mind about the solution and concept. Yeah, so the last problem in this video. So this problem is we have to prove it. Show that limit x tends to 0 minus, which is x cube cos of 3 by x is equals to 0. So this we have to prove it. Okay. First we'll plot a diagram. We'll plot a cos curve. Okay. This is y axis and this is x axis. Okay. So y is equals to cos x. X is 0. X is 0. Yes. Pi by 2. Pi. 3 pi by 2. 2 pi. Minus pi by 2. Minus pi. Minus 3 pi by 2. Minus 2 pi. Next here. 1 minus 1. Now let's draw the diagram. So at cos 0 is 1. Cos 90 is 0. Cos pi is minus 1. Cos 3 pi by 2 it is 0. Cos 2 pi again it is what? 1. Next cos minus pi by 2 0. Cos minus pi minus 1. Cos minus 3 pi by 2. Cos 2 pi is 1. So now let's plot the curve. So all the values it will be like this. Yeah. So this is the plot of cos x. So in this cos x, you can understand. So this is x-axis, yes or no? So this is x-axis and this is y-axis. Okay. So y is equals to cos x. So anything you input. So anything you input, any input you give from minus. So this is so on up to minus infinity. This is so on up to plus infinity. So this continues. So this is again this comes here and this goes. So this continues. This also comes here again. This continues. So for any value of x from minus infinity to plus infinity, what is the y value? So this value is y value is what? From minus 1 to plus 1. So anywhere it should come between these values. So what if we are inputting the values from x is equals to minus infinity to plus infinity, x equals plus infinity, the value should be minus between minus 1 and 1. So that should be there. Okay. So we can clearly say that the value of cos of x will be lying always between minus 1 and 1. I think you have got it. I'll be writing this conclusion. Clearly, the value of cos x lies between minus 1 and 1. So cos of anything, remember this very clearly, cos of anything is equals to, it lies between minus 1 and 1. So this is finite. This is finite value. So it is 1.1, it is minus 0.5 or 0.9 or 0.2, like that. So it is a number, finite value, number. So remember this one. This is very helpful for your competitive exams or for your board exams. So cos of anything is finite number, or sine of anything is a finite number. Similarly, sine also follows in the same way. So cos of anything lies between minus 1 and 1, and that has a finite value. So now let's go to the problem. What he has asked, limit LHS. I'm considering, just a minute. Consider LHS. Consider LHS. Limit x tends to 0 minus x cube cos of 3 by x. This is LHS. So here I am writing limit x tends to 0 minus h. This is x cube cos of 3 by x is equals to limit h tends to 0. In place of x we have to put minus h. 3 cos of 3 by minus h. This is equals to minus h whole cube. So 0 minus 0 whole cube into cos of 3 by minus 0. What I have told the conclusion just before, minus 0 cube is 0 clearly, into cos of anything. Cos of anything. So anything can be at what? 3 by minus 0 is minus infinity. So say it as 0 into cos of minus infinity. So you should not misinterpret as cos of minus infinity is infinity. No. Cos of minus infinity, it lies between minus 1 and 1. So it is a meaningful value. So 0 into cos of anything is what? 0 into finite number. Finite number. So any finite number into 0 is what? A big 0. Is a big 0. Okay. So then that is equals to RHS. Therefore, LHS is equals to RHS. Therefore, limit x tends to 0 minus x cube cos of 3 by x is equals to 0. hence prove. Yeah, so that's it in this video. I think this is a very, very, very long video. I think this is the first video, first very long video I've uploaded. So as all problems are of similar sort, I want to solve in a single video such that it will be very easy for you to follow. So yeah, that's it in the video. If you really learned a lot of concepts, so I'm very happy. And please like us video if you have felt that this video is very worth watching. So please hit a like button and subscribe to our channel Kanit Online. And if you have that sort of interest and if you want to share with your friends, please do it. Please share it among your friends and subscribe to our channel Kanit Online. Thank you.